All right, this is the 3 light bulbs conundrum. Okay, what I do is I've got the current, the conventional current is going to come in here, go through this light bulb, and then it goes here, and there's 2 light bulbs that could potentially be in series, right? And what I do is I unscrew this light bulb, and then I turn it on and turn up the voltage so that, oh, there we go. So the light bulbs are moderately bright, like that, okay? And then the question is, what happens when I put one in here that's going to be in parallel with that one? So these 2 in parallel are in series with that one, right? And I have the kids, they have to predict. If kids don't predict in a demonstration, they don't learn anything, right? Okay. And of course the answer is that when you allow another path beyond this light, right, more current's going to go through this light, but the current splits between these lights. So this guy gets dimmer, that guy gets brighter. Watch. Ooh. Right? You can point out at this point that that one's way, way, way brighter, right? And that's because power is I squared R. This is twice the current, right? So therefore it's 4 times the power, right? Okay. So it's a, there it is, right? I talk about series circuits too, right? And so like if you have your Christmas lights in series, if one burns out, they both go out, right? And then I ask them, those mini lights, those little mini incandescent Christmas lights, the question is, why don't those go out when one burns out? Because they don't necessarily, sometimes they do, right? And there's a clever answer to that, okay? The light bulbs are cleverly engineered to complete the circuit when they burn out, okay? They short circuit when they burn out. Anyway, and then the other thing I do is I put it like this, and I say, okay, what happens if I short circuit this bulb over here, right? I take this wire off, and if I go over here, it's going to short circuit it, and so the current, this will be a dead short, 0 resistance essentially, right? What'll happen to the brightness of this bulb and this bulb, right? And most kids will predict that this guy gets brighter and that this one turns off. Right? I don't want to burn that bulb out, but there it is. It'd be real easy to burn that guy out, right? And so, the reason what's going on here is that, of course, most of the current's going through, almost none goes through this because it has a fairly healthy resistance, right? Not nothing, though. It's not 0 through there. So that's a short circuit, right? And those Christmas lights actually slowly do that. Anyway, and then the question I always have is, where do you put this? I put it after they've learned about series and parallel resistances, because I think that they'll start thinking about network circuits, but they really don't understand. They don't predict very well for this, right? So maybe it's better after. I mean, I just don't know. I don't know. I just don't know. That's for you to decide.